Hello and welcome. Brandon here. Thanks for choosing my video. If you like the video, please give it a thumbs up. If you think someone you know can also benefit by watching, please share. And as always, please subscribe. I appreciate it very much. So let's go ahead and get started. So if this is the first video in this series you are watching, I'll go ahead and quickly set the stage. However, I highly encourage you to go back and watch the previous videos so this video makes sense within the context of the entire topic. But just a quick recap. So we have a series of 1,000 fictitious data observations, and we're interested in the probability that a person is approved for a home mortgage given their credit score. So we have a list of 1,000 credit scores and then a code of 0 or 1 representing whether or not they were approved for that home mortgage. So over here we only have 15 observations, but the full data set is 1,000. After running this logistic regression in Minitab, we were given this output. So again, we have coefficients here, and we can use those coefficients to generate an estimated regression equation down here in the lower right. So we have our constant term coefficient of negative 9.346, and you can see that down here in the equation in the lower right. And then we have our FICO score or credit score coefficient of 0.014634, and you can see that down here in the lower right. And again, P hat is the estimated probability of being approved, and the variable x1 is a credit score. So we would substitute any credit score into this equation where x1 is, and then we would get back a value for P hat, which is the estimated probability of being approved for a home mortgage given that credit score you substituted for x1. So let's go ahead and estimate some probabilities, and we'll talk about odds and some other things as we go forward. So over here on the left, I have a list of some hypothetical credit scores. Now at the top, I've highlighted the first one in red. That's a score of 655 or 655. Down towards the bottom, I highlighted another one in blue, and that is 745. Now notice that these scores are 90 points apart, and we'll talk about what that means here in a couple of minutes. So let's go ahead and do some calculations. So to calculate the estimated probability of being approved for this home mortgage, if your credit score is 655, we go ahead and do this. All we do is substitute the score of 655 into the estimated regression equation where the variable x1 was. So we go ahead and do this computation, and we end up with the estimated probability of 0.5595. Now, I will keep all the digits out for now, but I'm not going to read all of them. I'm going to keep them to eliminate any rounding problems we might have later. So the estimated probability of being approved, or P hat, is 0.5595. So all else being equal, if you apply for a mortgage having a 655 credit score, then the estimated probability of being approved is about 0.5595 or 55.95%, according to this model. So it's a bit better than 50%. Now what about a credit score of 745? So we do the same process. We substitute 745 in for the variable x1, and we do that computation, and we end up with an estimated probability of 0.8258. So all else being equal, if you apply for a mortgage having a 745 credit score, then the estimated probability of being approved is about 0.8258 or about 82.58%. So you can see that the difference between person A at the top with 655 and person B at the bottom with a score of 745, the difference is quite substantial, 55.95% versus 82.58% in terms of the probability of being approved for the mortgage. So now that we have some estimated probabilities, we can go ahead and talk about the odds. What we're going to do here is calculate the odds ratio for this 90-point increase in FICO score. So the odds ratio for a 655 to 745 FICO score increase, or 90-point increase, can be calculated like this. So on the top, we're going to have the odds of being approved if you have a FICO score of 745. In the denominator, we're going to have the odds of being approved for a FICO score of 655. So remember, the odds ratio is a ratio of two odds. So we'll calculate the odds for the FICO of 645, and the odds for the FICO of 655. So in the numerator, in the blue, we're calculating the odds of being approved for a FICO of 745. So on the top there, we have the probability of being approved, remember, was 8258, divided by 1 minus that. That is the definition of odds. So we go ahead and compute the odds for the FICO of 745, and we end up with 4.74138, etc. Now we do the same for the FICO of 655 in the denominator. So we have 0.5595 divided by 1 minus that. That's the odds. We go ahead and compute that, and we have odds of 1.2703, etc. And when we divide that, we have the odds ratio of 3.7324. So by increasing a score from 655 to 745, a 90-point increase, the odds increased by a factor of 3.732 and some change. Now, let's pick two more scores that are also 90 points apart. I picked these at random, so a FICO score of 600 and 690, a 90-point increase as well. Now, if we go ahead and do that computation, we end up with another odds ratio of 3.7324. So what is the general point we're trying to get across here? A characteristic of logistic regression is that when comparing the odds ratio for two scores that are the same distance apart, in this case 90 points on the credit score, the odds ratio is going to be the same no matter what two scores you pick. So we could pick scores of 700 and 790, just like we did 600 and 690. We could pick 650 and 740. In all those cases, the odds ratio will be 3.732431 regardless. So for any given interval, the odds ratio between them is the same as long as the interval is the same. So let's build on that and talk about some other intervals. So in this table on the left, I have a FICO score list on the left-hand side, and they're all 10 points apart. So 600, 610, 620, 630, etc., all the way down to 700. In the second column, we have the estimated probability, or p-hat, and we just calculated that using the estimated regression equation. So for a 600 credit score, the estimated probability of being approved is 0.362253, and then we can go all the way down to the bottom. If you have a credit score of 700, the estimated probability of being approved for the mortgage is 0.7105-ish. So you can see the p-hats there in the second column. Then in the third column, we have 1 minus p-hat. That's just 1 minus the probability to the left. So 1 minus 0.3622 is 0.6377. And that is pretty much self-explanatory. Then in the last column, we have the odds. So remember, that's just p-hat divided by 1 minus p-hat. So for a score of 600, we calculate the odds of 0.5680. Then we go all the way down to the bottom for a score of 700, and the odds of being approved in that case are 2.4542. So let's say you walk into the bank right now, and your FICO score is not very good, it's 600, and therefore you are not approved. Now, what if you work over the next year or two to improve your FICO score? How will your odds change over time? So let's look at the obvious one. If your FICO score does not change at all, then your odds are the same. So you have odds of 0.5680 the first time you walk in, and then they're the same the next time you walk in because your FICO score is the same. Therefore, you had a 0-point increase or change in your FICO score. The odds are the same, so the odds are 1. Now, what if you increased your score by 10 points? So you went from 600 to 610. So now we have the odds for 610, which is 0.657533, divided by the original odds when you walked in the first time of 0.568019. So we go ahead and do that division, and we end up with an odds ratio of 1.1576 or so. So you can see here that you improved your odds by a factor of 1.15 or 1.16 if we round up. What about if you increased your score by 20 points? So same process. Now we have the odds of 620 in the numerator, so 0.761154, divided by our original odds. So we do that computation, and we end up with an odds ratio of 1.340. So here, we've improved our odds by a factor of 1.34, or about 34%. And finally, what if you improved your score by 30 points? So 0.881104, that's the odds for a 630 score, divided by original odds of 0.568019. We do that computation and we have an odds ratio of 1.5512. So we increase the odds by a factor of 1.5512, or about 55.12%. Now the last thing I want to do is draw your attention over here to the table on the left. You'll notice that the scores of 630 and 640 I have turned green and turned bold. Now what makes those special? Well, if you look in the odds column, we can see that the odds for a 630 credit score are 0.8811. The odds of being approved for a 640 credit score are 1.0199, or about 1.02. Now, I don't want you to confuse these odds with the odds ratios over here on the right. The odds over here on the left are our original odds of being approved for a certain credit score, an individual score. Our odds ratios over here on the right is a comparison of two odds. So two different things. But back to the chart over here on the left, we'll notice that an odds of being approved of 1, so even odds of being approved for the mortgage, is somewhere between 630 and 640. And that was one of our original questions way back in the first or second video in this series. We wanted to know at what credit score is the probability 50% of being approved, or in other words, the odds are even. And we'll talk about how to do that here in a second. So let's talk about the effect of improving the FICO score for certain intervals. So over here on the left, I've sort of summarized if we were to increase the credit score by a certain amount, what the odds ratio would be and what percentage increase that would be. So in the first row, you can see that if we don't increase our credit score at all, let's say we apply the first time, we're not approved, we increase our score by a certain amount, and then we come back, what's the odds of being approved? So a 0-point increase or a 0-point change would mean an odds ratio of 1 because it's the same, and a 0% increase of being approved. Now, if we increased our credit score by 10 points, we determined that that odds ratio is 1.15759, or we increased our odds by 15.76%. If we go all the way down to the bottom, if we increase our credit score from the first time we apply to the second time we apply, we have an odds ratio of 4.32. So we increased our odds by a factor of 4.32. And that means we have a percentage increase in our odds of 332.06%. Now, an important point. This is the percentage increase in the odds, not the percentage increase in the probability of being approved. So we have a percentage or probability of being approved for each individual score. That's not what we're doing here. We're looking at the percentage increase for two different scores, using the odds of each score and taking the odds ratio to find the percentage increase. So just keep those two things in mind. This percentage increase relates to the odds ratio, not the original probability for an individual score we did at the beginning. So, if you watched many of my videos by now, you know that I love to graph things. So let's go ahead and make a graph of the increase interval over here on the left. So an increase of 0 points between the two applications, 10 points, 30 points, 100 points, and that increase interval's associated odds ratio over here in the second column. Okay, so here's the graph we're going to use. Now down at the bottom, we have FICO score change, or that's delta. Remember, delta means change. So if the first score is, 600, and then the second score, when you walk in the second time to the bank, is 660, then we're going to look at the FICO change of 60 here on the bottom. And then when we go up, we will have an odds ratio associated with that change of 60 points. And again, that's the same for any change here along the bottom. So let's go ahead and graph what we had from the last slide. So we have a nice smooth curve. And just to reiterate a few points, the most obvious one is 0. If our score doesn't change at all, then the odds from one score to another doesn't change. Therefore, the odds ratio is 1 because the odds are the same from the first score to the second score. Now, what about a FICO score change of 50? So we can go to the 50 change or the 50 delta down here at the bottom. and we can look over at the number or the axis, but we have an odds ratio of 2.0786. So if our score increased 50 points, our odds increased by a factor of 2.0786, or about 107.86%. And again, we could do this for any score along the bottom. Remember, this is FICO score change from one score to the next. Now, what if we take this data and we fit an exponential regression line to it? So we have our original data, and we're going to fit a regression line, an exponential regression line. Well, when we do that, we get this. We get y equals e raised to the power of 0.0146 times x. So that is the equation of this regression line. Now you can't see the regression line on this graph because it's the exact same as this line. They're on top of each other. They're perfectly on top of each other. And we know that because the r squared is 1. So that means there is no difference between our original data, the curve, and the exponential regression line, y equals e raised to the power 0.0146x. They are the same thing. Now, of course, that's pretty important. That's not going to happen just by chance. Now, hopefully by now, you realize that you have seen something like this before. That's because you have. So in our original estimated probability, so our estimated regression equation way back when, you will see that we have 0.014634 as a coefficient in that equation. Well, we also have that up here in this regression line that we fitted to these points. Coincidence? Absolutely not. So what we're trying to point out here is some underlying characteristics and properties of logistic regression. So if we graph the odds ratios for different intervals, so from score A to score B, like a score of 600 to 620 or 700 to 750, so a 20-point change, a 50-point change, whatever, if we graph those odds ratios for any interval of change in two scores, we're going to get back a regression line that looks a lot like our original regression equation. That's because, of course, they are fundamentally related. So what we can do is generalize. So y equals e raised to the power of our beta 1 coefficient, which is over here in the red, 0.01463, times whatever score change we are interested in. So a 10-point score change or an 80-point score change doesn't matter. So we can go ahead and do that out. We end up with y equals e raised to the power of 0.014634. That's our beta 1 coefficient from our output, times whatever delta or whatever change we are interested in. And when we evaluate that, we will get the odds ratio for that change. Let's go ahead and walk through a few very quickly. So here we have y equals e raised to the power of beta 1 times delta. So beta 1 is our coefficient times the delta is the change we're interested in. So y equals e raised to the power of 0.014634 times our delta. So let's say we're interested in a 1-point increase on our credit score. So what is the odds ratio for that? We just take e raised to the power of 0.014634 times 1, because that's the change we're interested in. And we get back an odds ratio of 1.0147 or 1.47%. And guess what? That is what Minitab reported back to us in the previous video. So if you look at the output, they'll say odds ratio 1.0147 because it gives back to us the odds ratio for a 1-unit increase in our variable. So in this case, it's 1 point of a credit score. So we have 1.0147. What about another one? We'll pick this randomly. Let's say our score increased by 19 points. So we had a delta or a change of 19 points. Well, we just substitute that in where our delta is, and we have an odds ratio of 1.3205 or a 32.05% increase in our odds. What about a 53-point increase in our credit score? Do the same thing. Now our odds ratio is 2.1719 or a 117.19% increase in our odds. And finally, let's say a 74 increase. Odds ratio 2.9533 or a 195.33% increase. So you can see the power here. We can figure out the odds ratio for any change in two credit scores. We can easily compute the odds ratio or the percent increase for that change. Now, one of the original problems we wanted to know was what credit score would give us even odds. So we walk into the bank with a certain credit score, and the odds of being approved is a coin flip. It's 50-50. We want to know what that credit score is. So we can do that algebraically. Now, I'm going to start back at the beginning. You could probably start anywhere in this algebraic process, but I like starting out sort of at the beginning so you can see how everything is put together. So here we have our original equation from like video 2 in the series, I think it was. So we have the natural log of the odds. Of course, that's called the logit over here on the left-hand side of the equal sign, equals the linear combination of our variables. Now, for a 50-50 situation, the probability is the same of being approved or not approved. So we have p equals 0.5, and 1 minus p is also 0.5. So 50-50 probability. We can also substitute in what we have for our regression output. So we know that the intercept coefficient is negative 9.346. We know that the FICO score coefficient is 0.014634, and it's times x1. So what we're doing here, we're going to solve for x1. But remember, x1 is the credit score. So we're going to use this information algebraically to solve for x1. So we have the natural log of 1 equals our linear equation, but the natural log of 1 is 0, which makes it easier. We'll keep going. So we swing the 9.346 over around to the left. We go ahead and solve for x1, and we end up with 638.65. So what score would you need to walk into the bank with to have even odds or a 50-50 probability of being approved for a home mortgage? It is 639 approximately. So to have a 50-50 chance or even odds of approve, disapprove, you will need to have a FICO score of approximately 639 according to this model. Now, we're going to have a bonus question here, so if you want to pause the video to figure it out, do so now. And that is, compute the FICO score you would need to have odds of 3 to 1, or odds of 3, which is another way of saying a 75% probability of being approved when you walk into the bank. So if you want to use this slide to figure that out, go ahead and pause the video now, and then we'll come back in the next slide and solve it. So here's how we solved it. It's the same way we did the other one. So we have the natural log of the odds, so that's the logit. So 0.75 divided by 0.25 equals our linear combination of variables. So now we have the natural log of 3 equals our linear equation. So the natural log of 3 is 1.098612. Algebraically, we swing the 9 over to the left, so we add that to 1.098612. So we have 10.444612 equals, then we have 0.014634. We go ahead and solve this algebraically, and lo and behold, we end up with 713.72, or about 714. So to have a 75% chance or 3 to 1 odds for approve, disapprove, you will need to have a FICO score of approximately 714 according to this model. Okay, so that wraps up this video on logistic regression. Now in the next video, we're actually going to go into Excel. We're going to conduct the logistic regression. Yes, there is a way to do that. It's not native to Excel, but there is a way to do it. And then we will actually plot the regression curve and learn how to interpret it related to our output. And then we'll compare all of that in Excel to what we've been doing here in the videos. So stick around for that. Thank you for watching, and I look forward to seeing you again next time.